Good afternoon, everyone. Today we're going to find the domain and range of f of x, meaning a composite function, where f of x is called to be 1 over x plus 1. Okay? So, because we have a composite function, we have f of x, meaning we replace x, whatever's inside of the bracket in the original f of x function, with the stuff that's inside the bracket here, which is itself f of x, right? We have big brackets around f of x. So what used to be inside the brackets, which was just x, is now replaced with f of x. Meaning we put f of x inside of x everywhere we see it. So what that looks like is f of x is 1 over, every time we see an x, we replace it with f of x. So x becomes f of x, which means 1 over x plus 1, right? That is f of x. X becomes f of x, and the rest looks the same. And so we have 1 over x plus 1 plus 1. Now we can clean this up a bit by getting a common denominator in the denominator itself, and that'll look like 1 over x plus 1 plus 1 is the same as x plus 1 over x plus 1, right? In the search for a common denominator, right? So now that we do have our common denominator of x plus 1, we can go ahead and add the numerators. And so we have 1 over 1 plus x plus 1 all over x plus 1, right? Let's take this up here. So that becomes 1 over 1 plus x plus 1 is x plus 2 over the smaller denominator of x plus 1. And now what we really have is 1 over all of that, right? And so we're dividing 1 by a fraction, which you learned a long time ago is the same as multiplying by the reciprocal of that fraction. And so this, if we do that, becomes x plus 1 over x plus 2. Okay? So that means that we have a vertical asymptote at is x is equal to -2, right? This is a linear over a linear, and so that means we're going to have a horizontal asymptote at 1 over 1, so y is equal to 1, right? Let's move a colon here. Y is equal to 1 for our horizontal asymptote, and from that point forward, we're going to get a 1 over x function, and so we're going to go off to positive and negative infinity in both y and in x. And so writing, let's use a different color for the domain range, our domain would be x such that x can't be -2 and xcr, and our range would be the y value such that y is never going to be positive 1, right? Since we have a horizontal asymptote, we're never going to cross positive 1. Sometimes there are exceptions to that, right? If we have double roots or something like that, but we obviously don't have any double roots. We have a single root at x is equal to -1. That bottom portion of the graph will catch that one, and so we know we're not going to have anything cross our horizontal asymptote. You can check it on a graph if you'd like. So the only restriction on y is that y is never going to be positive 1, but other than that, y can be any real number. Okay? And we're done. So again, illustrating the concept of whenever we have composite functions, whatever is inside of the big bracket, we replace what used to be inside the bracket with what is now inside the bracket. So we replace x with f of x, and then we go through the process of simplifying algebraically and reading off the domain and range from the function that comes out of it. Okay. Hope this helps. Thanks for watching. Take care.